Hi friends, today we will be discussing about the nucleophilic substitution reactions, that is Sn1 and Sn2 reactions. These reactions are very important from exam point of view. So let's learn the mechanism and properties of these reactions. First of all, we'll start with Sn2 reaction. Generally, these reactions takes place using alkyl halide as the substrate or reactant. So let's see the mechanism of Sn2 reaction first. So Sn2 reaction basically happens where the substrate is a primary alkyl halide. This substrate is attacked by a nucleophile. The nucleophile attacks the alkyl halide from the backside such that a 5-member transition state is formed. This is a 5-member transition state which is being formed by the attack of the nucleophile. In the transition state, the bond between carbon and OH is starting to be created and the bond between C and Cl becomes weakened. So the 5-member transition state is created after the attack of nucleophile onto the alkyl halide, which ultimately results in the formation of the product. Well, this is the Sn2 reaction. Now let's learn about the properties of these reactions. Well, this is Sn2 reaction, so we call it as Sn2 since this is a bimolecular reaction. Now, why is it called a bimolecular reaction? That is because the rate of the reaction depends upon concentration of base as well as the concentration of the reactant. So here base is basically used as a reagent. So this is a bimolecular reaction. Secondly, the reaction proceeds via the inversion of configuration. Well, we are seeing that the nucleophile is attacking the alkyl halide from the backside. Thus, the product which is formed has an inverted configuration as compared to the reaction. So the reaction proceeds via inversion of configuration. Since we are seeing here that the nucleophile is attacking from the back side, so it is very important that the alkyl halide that we are taking in Sn2 reaction is comparatively less hindered. So the reactivity of Sn2 reaction is that the primary alkyl halides react faster as compared to secondary alkyl halides, which react faster as compared to the tertiary alkyl halide. So this is the Sn2 reaction where we have learned the mechanism as well as the properties. Now let's look at Sn1 reaction. First of all, we have to look at the mechanism of this reaction. So again here we have an alkyl halide which gets converted into the carbocation first. In this reaction, first of all, the Cl minus migrates, which results into the formation of a carbocation. Then the nucleophile attack takes place, which results in the formation of a product. So this reaction is 1 degree reaction. This reaction is Sn1 reaction. Now we are calling it as Sn1 reaction since it is a unimolecular reaction. That is, the rate of the reaction only depends upon the concentration of the reactant that we are taking, and does not depend upon the concentration of the base, and that is why it is the unimolecular reaction. Now here the reaction proceeds via the formation of carbocation, unlike Sn2 reaction, which proceeds via the formation of a 5-member transition state. Then, since the reaction is proceeding via the formation of a carbocation, hence it is not a backside effect. Thus, the product formed in this reaction forms via retention of configuration. Now we cannot be really sure whether the product is 100% retented or not. Hence, the 50% retention is attained in this reaction. Thus, the formation of racemic mixture takes place. And since the product is being formed via the formation of a carbocation, hence the reactivity of the reaction is highest for 3 degree carbocations, since 3 degree carbocations are more stable as compared to 2 degree carbocations followed by 1 degree carbocation. So the reactivity is highest for 3 degree alkyl halides followed by 2 degree alkyl halides followed by 1 degree alkyl halide. Now this was the property and mechanism for Sn1 and Sn2 reaction. Now let's look at some of the reactions of Sn1 reaction. Now suppose if we have a normal 3 degree alkyl halide, that is this structure, right? So after the elimination of chloride ion, the carbocation can be formed. So this is a 3 degree carbocation, and simply after the addition of a nucleophile, it can lead to this product. So this is the reaction when a simple 3 degree alkyl halide is used, right? If suppose we have an alkyl halide of formula this, then how the reaction proceeds in this case? Well, again here the reaction first proceeds via the elimination of chloride ion, which leads to the formation of this 2-degree carbocation. Now carbocations have a tendency to rearrange themselves if possible in the most stable carbocations. So here we can see that if a hydride ion shifts to this carbon where a positive charge is there, then this 2-degree carbocation can be converted into a 3-degree carbocation. A hydride shift has taken place from this carbon atom to the carbon atom having the positive charge, which has led to the formation of a 3-degree carbocation. Now since 3-degree carbocation is more stable as compared to the 2-degree carbocation, hence the reaction will lead to this product. So here hydride shift has taken place. Similarly, if we have the alkyl halide of this form, then how the reaction proceeds? So first of all, the reaction will proceed via the elimination of the chloride ion, which leads to the formation of again a carbocation. So again this is a 2-degree carbocation. Now since carbocation has the tendency to rearrange themselves into a stabler form, thus in this case a methyl shift will take place, which will lead to a 3-degree carbocation. Methyl from this carbon, this methyl from this carbon will shift to the carbon carrying the positive charge, and thus will create a positive charge on this carbon atom, and thus results in the formation of a 3-degree carbocation, which ultimately would be attacked by a nucleophile and thus will form this product. Similarly, if we have a phenyl instead of a methyl, then phenyl shift also can take place in order to rearrange the carbocation from 2-degree to 3-degree, and thus the product will be formed with a stabler carbocation. So this was about Sn1 and Sn2 reaction. These reactions are very important from your exam point of view. I hope you like the video, and this video is also beneficial to you. So if you like the video, please like, share and subscribe, and thanks for watching.